All right, so working together, Daniel and Ronnie can clean the llama pen in 45 minutes. On his own, Daniel can clean the pen in an hour. How long does it take Ronnie to clean the llama pen on his own? All right, so this is one of those work problems. So this is going to be work is equal to rate times time. Okay. Now, what kind of work are we doing? Well, we're cleaning a pen. So the work is going to be clean the llama pen. Okay. Now, what does it say? It says we want to look for the Daniel knows he can do it in that one. Ronnie is what we're looking for. And so, our rate, I guess we should write all these down. Rate is equal to one. We want clean pen, not just one pen. One clean pen per hour. So we're going to break it down into a rate pen per hour. Okay. And so, our time is going to be then in hours because we're going to take one clean pen per hour times hours. We're going to get one clean pen, and that's what we have here. So that's kind of the format we're going to be working with. And so, what does it tell us? Well, it says Daniel. I'm going to try to say Donnie because we did Donnie on the last problem. And so, and we have a Ronnie here. So Donnie and Ronnie just go together. It says Daniel can clean the one pen in 1 hour. So we know that's Daniel's rate. And then it says Daniel and Ronnie together can clean one pen in 45 minutes. Well, how long is 45 minutes? Well, that's 3/4 of an hour. So I'm going to have to convert that minutes to hours because everything else is in hours or per hour or something else. And so then I can say, well, Daniel plus Ronnie is equal to 3/4 of an hour. Okay. So what does that mean? It says one clean pen per 3/4 of an hour. Now, could I simplify that? Well, yeah, I could say, well, that's equal to 4 pens clean per 3 hours. Now that doesn't really help me because I want one clean in an hour. So that's kind of a thing that we can maybe use in a little while, but right now it doesn't make sense. This is kind of more along the lines of what we're going to use. All right. So what are we going to do then? Well, we're going to have to think about the rate of the total. So the total rate is going to be equal to what? Well, it's going to be the rate of Daniel plus the rate of Ronnie. Okay. Well, the total we already said was 45 minutes. So it's going to be one pen per 3/4 of an hour. And that's equal to his rate. Well, that was one pen per 1 hour plus R of R. And we don't know that one. That's what we're looking for. So we did all these other things to get it to the point where we can plug it into this formula and determine what our rate was. Well, what we're going to have to do is we're going to have to subtract this over here. And so R of R is going to be equal to, now, if we think about this, that's in 3/4 of an hour. We want kind of more like hours. So now maybe we can substitute this for pens per 3 hours minus one pen per 1 hour. And what can we get then? Well, we can say, okay, well, if we take that times 3 over 3, we'll have 4 minus 3, which is 1 pen, 3 hours. And so it's basically 1 pen per 3 hours. So it's going to take him 3 hours for Ronnie, to do one pen cleaning. So we'll say then Ronnie takes 3 hours to clean one pen. Okay. So quite a while to clean the llama pen for Ronnie, whereas Daniel cleaned it quite quickly in relation to that. Okay. And so here we could have left it as one pen over 3/4 of an hour, and then we could have got, common denominator again and done all that. And we still would have ended up with one pen per 3 hours because we had the common denominator of 3 hours. All right. How about the next one? So here we have a function. It's a cost function. So it's 0.03x cubed minus 4.5x squared plus 225x plus 250, and x has to be greater than or equal to 0, and it's going to model the cost to produce x porta game systems. So using this cost function, find the number of porta which could be produced to minimize the average cost, C bar. And so basically, how do we find C bar? Well, C bar is, if you think about that, what is X bar? Well, that's the number divided by the the totals. And so we're taking the average, the cost, whatever your number is, how much that cost, divided by however many X boys we're going to produce. And so that's going to give us an average cost. So that's kind of what we're doing, C bar instead of X bar. And so that's the way it's going to be. So what do we need to do here? Well, now what we're going to do is think about how did we get to C bar? Well, we're taking C of x, which is 0.03x squared cubed, minus 4.5x squared plus 225x plus 250, and we're dividing that by x, and that's going to give us C bar of x. Okay, so what we actually have then is 0.03x squared, because that's going to divide each one of those, and then minus 4.5x, and then plus 225, and then plus 250 over x. Okay, so that then is going to be our function we need to look at. And so how do we find the minimize? Well, we're going to plug that into our calculator and use the nice minimize function. And so let's go ahead and plot it. So we have the 0.03x squared, and then we have the minus 4.5x, and then plus 225, and then plus 250 divided by x. And so with big numbers like that, let's go to our window, maybe, I don't know, 100 to, that's probably gonna be bigger. I don't know, let's go by 100 since they're so big numbers. Maybe negative 2, oops, 200 up to, I don't know, it's gonna be maybe 500. And again, we'll go by 100. I don't know what we're gonna get, but all right, so that gives us kind of what that function looks like. So we have that going down to negative infinity, and then we have this part going up like this. And ideally, this is where our minimum is. So where do we do that? We do second trace, do number 3. And let's go over here somewhere and choose that as our left bound. We'll come over here again somewhere and choose that as our right. And then somewhere here in the middle, that's going to be our actual minimum. So 75.73 and 59.57. So let's write that down. So we had so we used the calculator to find minimum, and that was at 75.73 comma 59.57. Okay, now x's are the number of portable game systems, and y is going to be the average cost. Now, can we make a 0.73 game system? Nah. So let's round that up to an even number. So let's go back to here, and let's say we want to find at 76, because that's going to be what we would round to. We'd round it up, and that's going to be the cost for an even number of systems. So 59.57. So we're going to say round up and use calculator again, and we get 76 and 59.57 again. So, we got pretty close there with that one because it was 5.6 something. We rounded it to 5.7. And so that tells us then, using this cost function, find the number of porta boys we're going to produce. So we're going to produce 76 porta boy game systems. And does it ask for the average cost? No. And the average cost is 59.57 based on our function we found here. So that would be our value. That would be our sentence written out as far as what we want and find. And so that would be how we would answer that question. All right, so let's pause there and come back for more.